Last time we spoke about systems, and today we will be speaking about structural systems. If I have, by means of design, determined that my building should look like this, now I could try to support the ceiling. And it could be a primary beam and secondary beams in this direction and beams in this direction. This is maybe what most people would do. I could also design it the other way around by creating a beam here and then the secondary beams in that direction. Okay, and if I say I want to have the same span for both halves of the plan, then I could also say, okay, I create an additional support here, and then this span and this span are alike. Here's another example. If I have a structure consisting of 9 fields like this, and it's supposed to be a load-bearing structure, and I don't want cantilever, and I want the columns to receive the same load. So I've been starting here to draw a solution, but it doesn't have cantilevers, that's okay. But I will see that this column here at the corner receives 1/4 of a square. Here in the middle, it receives 4/4. And at the side here, the load is 2/4. This one here has 4/4 again. So in fact, this column should be much bigger than this, and this could stay the same. So the second is not respected. So let me try out something else. I could put the columns in the middle of the fields. Then the load would be the same for all of these columns here. Same, 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 same. But I would have cantilevers here. So you won't know what I'm drawing here. I'm drawing something like this in section. Here's a human being. And then the next could be the same, and this could be the same again, but here I would have a cantilever. So this wouldn't respect the cantilever condition. So let me try a third solution. Third solution would be putting 2 columns here. 1 column here, 2 columns here, and 4 columns there, so that each one of the columns will receive the same load, which would be 1/4 of a field. So that's respected, no cantilever respected as well. And this becomes a table structure where I design one element resembling a table, and then I can add more of these elements to each other. I could make it architecture by pushing them around, or by putting bigger columns below this, as has been done in the Adler house of Louis Kahn's in, I think it was 52. So here I have a surface that I want to create, and the surface is supported by these lateral beams, which are the secondary structure, and these beams are supported by the primary structure, which is the truss going from one foundation to the other. And you can see the same above me. where the surface is the corrugated roofing material, and it sits on the secondary structure which is doubled up by wooden sections to curve the corrugated metal, and then that sits on the trusses, and the trusses are connected to the columns, and this is bracing to avoid that the whole thing will bend over to one side or the other. Here above me, primary structure linking the columns to the concrete wall, and then secondary structure in the other direction. So here we have a pedestrian bridge linking one building to the other, and as you can see, there's the walkable surface being supported by the secondary beams, and the secondary beams being linked by two primary beams. And the primary beams are supported twice in the middle by the cables, and the cables suspended from the building surface here on the right. So here above me we have a waffle slab structure. So the waffle slab structure normally is good for square surfaces where the span is the same in both directions. So in this case, it's not exactly the same span in both directions, because we have primary beams here interrupting the waffle slab structure. But in general, it's not ideal for this type of rectangular space.